Hello everyone, Sean here from Assembly Methods. You are very welcome into this video in which I am going to augment a PLC template that I created in a playlist in this channel with an IO-Link device, specifically an IO-Link Lite. Now that PLC template, which I've provided a link to the playlist in the description for this video, was presented as the base point or starting point from which solutions for the PLC tasks in the regional qualifier stage of the automation discipline in WorldSkills could be generated. But truth be told, that PLC template is a very viable starting point for the Mechatronics solutions as well, the task C in the regional qualifiers for Mechatronics. For 2024, however, there has been the option of using an IO-Link Lite in the PLC solution, with the benefit that if you did use the IO-Link Lite as opposed to the alternate option of using a standard red, amber, green traffic light solution, that 3 additional points were up for grabs, provided of course that it was configured properly and it operated in accordance to the circuit requirements. So that PLC template as it stands at the minute that we created does not have any sort of pre-configurations or anything loaded in to help us along the way of including in an IO-Link device. So I want to remedy that, and I want to upgrade this PLC template so that it also has faculty for the IO-Link device, the IO-Link Lite. Now, it could be any sort of IO-Link device that you are given. It could be an air pressure sensor, it could be an airflow sensor, it could indeed be a light, it could be a proximity sensor, who knows, it could be anything. I'm going to use a light. But if it's not a light that you're given in this competition, or indeed if there's some other IO-Link device that you want to configure or add into this template, the process of configuring the channels in the IO-Link master and the CM, the communication module, will be more or less the same. So what we'll do is we'll go through the steps of bringing in the IO-Link device, whether it be a light or sensor or whatnot. It just so happens that I'm going to use a light for this example. So this is the light that I'm going to use. It's a Balluff light. The model or the product number is a BNI IOL-800-000-Z036. Now this Balluff light is the same light that was provided by competition organisers to competitors in the Mechatronics competition at regional final level in 2024 and 2025, and I have it connected via an M12D type connector, which is into a 5-wire sensor cable. The light itself only uses 4 pins. I have a 5-pin cable, and I have it connected into my ET200 PLC behind me, and it's wired into the first channel or the first port in the IO-Link master that I have on that PLC, or the CM, the communication module. So let's get started on how we get this IO-Link device on. So this here is the template, and again I've provided a link to the playlist for the 6 videos that I laid out the creation of this template in. If you haven't seen the creation of the template or gone through that workflow, I highly suggest you do, because it'll leave it an awful lot easier to understand what I'm doing here. Whether it's sensible in, holistically or not, I don't know, but any sense that you have, or any chance that you have of making sense of it, will be vastly increased if you had seen what I had done up to now. So what I'm going to do is I'm going to come straight on into device configuration, and I could see my setup here. This is my ET200 complete with the 2 digital input cards, 2 digital output cards, and my communication module, or my 4-channel IO-Link master, 4-port IO-Link master. So what I want to do is I want to configure to this port, or configure to this here, configuration information for this particular light that is wired to the first port on that card. Now I could see on the light here, or see in the light, that there is like a lime green pilot light emitted, and it's on solid. What that indicates is that the unit is powered. A flashing light, or intermittent light, indicates that not only is it powered, but it's communicating. So there's no communications with this. This is just receiving power from the IO-Link master, but there's no data transfer happening. This is what I need to I need to instigate. I need to get this going. I need to get the I need to get the two talking, the PLC and the light talking. So it is a smart light in that it carries its own sort of code and its own sort of configurations within it. It doesn't completely depend on the PLC to tell it what to do. It does have its own sort of programming. And the programming that I do on that is going to be done within the link master here. So if I right click onto this, I can start the device tool. Now the device tool here is black. Sometimes you might click this, or some people might right click this and they'll see that this is grayed out. If it's grayed out, do not worry, it's not the end of the world. It simply means that your S7 PCT standing for port configuration tool, probably hasn't been installed, likely hasn't been installed, or hasn't been patched in at the time that your version of TAA had been installed in itself. If that is the case, all you need to do is go onto the Siemens website, and provided that you are a registered user, if you're not, again, not the end of the world, just register yourself. Once you log in, then you'll be able to search in the downloads, and if you do Google Siemens search an S7 PCT, that'll bring you up to a list of the download files for. So there's different versions, and I don't know which version I have installed in this, but it would have been the one that was contemporary with this TAA 17 that I'm operating on here now. But certainly download one of the PCTs and install it, restart. Next time you start this up here, you should have the option to start the device too. Now, before I actually do that, what I'm going to do is I'm going to just click on this. I'm going to Alt Enter to open up the properties for this card. And one of the things that we did in the first video of the playlist for creating the PLC template was we changed a few parameters on the IO addresses section of this CM. This is CM again, communication module. One of the things we did was on the IO addresses, the input-output type, we changed that from what I believe was a default 88 to 6464. Now, you can change it to whatever you like. I always use 6464. And what is that? Well, that's the amount of memory that I have allocated for the input, 64, and the outputs is also allocated there with the 64 bits. The start address here for the inputs, I have it starting at 10. Right, the default was at 0, right, which would be %I0, which is my first byte in the input, and the same with the output. I started my output addresses at 10, which would be $Q10 in Siemens, all right, where the default would have been $Q0. Now, obviously, $I0 and $Q0, and indeed I1 and Q1 are allocated. They're already taken up, which I probably did maybe in video 2 or 3 in the PLC tags, my digital inputs and my digital outputs. My inputs we can see are running from $I byte 0 bit 0 all the way up to byte 1 bit 7. And same with the outputs, $Q byte 0 bit 0 to $Q byte 1 bit 7. Right, so bytes 1 or 0 and 1 of both the input and the output are allocated. The register for Siemens, I believe all the inputs and outputs and memory bits are all mashed into the same register. There is no organization of it. Again, stand to be corrected on that one. But I could likely have had a clash if I did leave that at a 0 and 1, being that I have digital inputs at zeros and ones, and now I could be potentially throwing my IO link inputs to 0 and 1. So I don't want that. So what I did was I moved any inputs associated with IO link devices to start at bit 10 or byte 10, and any outputs associated with my IO link devices to be associated with byte 10 on the outputs, the Qs. Now, IO link devices could have inputs and outputs in the same device. Some might only have inputs, some might only have outputs. So this is an example that only has outputs. There is no inputs in this, right? So any output data, output memory that I have for this is likely to be starting in, well, it has to be, it will be starting in Q10, $QB10 or $Q10.0, okay, into this device. So that was set up in an earlier video in the template creation. So I'm going to right click back onto this one again, and I'm going to start the device tool. S7 port configuration tool, PCT. This is the tool that I want to start. Configure IO link is being prompted, and I'm connected in. So what I have down here on I'll have a tree, a hierarchical tree, start with my PLC, down to my communication card, and then down into devices that are connected to the communication card. So that's just a regular PLC. On my PLC, I have a communication card, a IO Link Master, and on that Link Master, and I have ports, and I have 1, 2, 3, 4 ports. So it's a 4-port or a 4-channel IO Link Master, right? Each one of them ports is going to have certain addresses, and I can address in any inputs up to 64 parts of data or bits of data, and same on the output. All right, and then I can also check status, my INM and my commands. But specifically on the port is what I first need to configure. So I need to tell this IO Link Master that I have this particular device, right? This BNI IOL-800-000-Z036 device connected into its top port. It doesn't know there's anything connected to it at the minute, but I need to tell that. So what do I need to do? I want to populate port 1 with a configuration file for this particular device. Now the configuration for that device is called an IODD, right? Or the configuration file for any IO Link device is going to be called the IODD. Now that in the competition that'll be given to you likely on a USB stick, or you might be given an address or a server address to download it from, or you will be, well, you'll have to have access to that. As soon as they give you the hardware, this hardware is absolutely zero good without the configuration file for it, the IODD file for it. If you're like me and you just have it and you need to configure it, or you need to get the device, what you'll generally do is go online. Just go online, and what I'm going to do is I'm going to do a search here for IODD Finder. IODD Finder, and you get a couple of ones coming back. Profitest-online.de. Let me just get rid of all that there. io-link.com, Siemens Cloud, IODD Finder-PI China, blah blah blah. I'll tend to nearly go with this one here all the time, right? IODDfinder.io-link.com. This is the one that hasn't failed me yet. So what I do here is I search for the manufacturer, and in the first prompt, Balluff is the manufacturer of this light. I'm going to click into this, and now I'm going to go into product name, and this filters as I type, and this is a BNI. See it filtering as we type. Space IOL -800 000-Z036. So there's two of them there. And you will see two of nearly every part number. And the reason you see two of every part number is because IO-Link has two main revisions, 1.0 and 1.1. Now, I've been using IO-Link since 2022, 23, and I've always just known it to have 1.0 and 1.1. I've never seen an IO-Link Rev 1.2 or 1.3. These have been here for years. So I'm not overly au fait with what is in 1.1 that's not in 1.0, and there must be something about 1.0 that 1.1 doesn't have, because 1.1 is not a superseding revision, right? It's not an upgrade. If it was, 1.0 could have been gone last year or 2 years ago or 3 years ago or even this year, but it's hanging on, and that's the case for all these devices. But what I'm going to do is I'm going to go for the 1.1. So what that's going to have here, you see my standard catalog in the port configuration tool. By standard, I just have Siemens devices. Obviously, this is a TIA programming platform. It's going to give me standard Siemens IO-Link devices, and then standards just for generic devices to put in. What's going to happen now is I'm going to download 1.1 for this particular model. This is the light that I'm dealing with. And click download. I'm going to accept that. Let it download. Hopefully it will download. There we go. Not going to bother opening it. We can notice it's a zip file. Going to minimize that. Come back in my port configuration tool. Come up to options. I'm going to import an IODD. Okay. What I'm going to do is I'm going to browse for it here. There's my downloads, and voila, there it is. Now the beauty on this port configuration tool, or when I bring in the IODD, is I do not have to first unzip the zip file that I've downloaded. I just select the whole zip folder. Now within that zip folder, I will have the CSV file or whatever the format file is for the configuration data for the device. I'll have the product photos of it, maybe a data sheet. I'll have a whole heap of the user manual could be in it, a whole heap of data in there. But the S7 PCT will be able to pull out the relevant file and import it here into the import interface. So I'm going to select the zip file, click open, and there it is there. It pulls out the relevant stuff. When I see that, I'm going to go on ahead and click import down here in the bottom left. Hopefully that'll go all nice and green. I'm just going to plug in Ethernet here. I did take out the Ethernet just to go online. Okay, I can see that this has been successfully imported, right? So once it's successfully imported, I'm happy enough I can close. Job done. Now what I can see is in version 1.1, I see an additional folder here, an additional directory for Balluff, right? IOLink 1.0 does not have it because it is a 1.1 revision that I brought in. So dropping that down, I can see that the IODD file that we brought in was for BNI SmartLight, and indeed it was for this specific model. I'm going to click this file here and drag, and I'm going to drop it onto the port to which that this is wired into via my M12 D-type connector, which is the top port here, top channel. And that's it. Compatible, everything is hunky-dory. That is that now attributed to that. Now, what's so great about it? But now you see here, so I have the PLC, I have the IOLink master onto the PLC, and I have this connected into the IOLink master. So having a look at the IOLink master, let's just have a little bit more. I have one port filled with it, with that. If I go into the addressing on this, what I can now see is, according to what's connected to it, how is this IOLink master going to be addressing? I'm going to I can see here that on port 1 of it, right, from a memory perspective and addressing perspective, I have 1 byte of data, and it's an output byte, 0.0 to 0.7. So it's 8 bits, 1 byte of data, only on outputs. I have nothing here in the inputs on port 1. So this device here only has outputs to it. When I click show a PLC addresses, what it's going to do is it's going to take information from here, from the start addresses. I won't be able to scroll that down because this is active, but the input address starts at 10, the output address also starts at 10. So when I click show PLC addresses, we'll see this update to 10.0 to 10.7, so still 1 byte, but where I'm starting from has now been offset up to byte 10 from byte 0. Okay. Now the structure of the process data is in here. Everything is occurring on byte 10. Byte 10 is my process data. Now this is slightly misleading, not slightly, it's wholly misleading on how this is set up. The way this would appear is that the process data, the color of segment 1, so just say the color of the light, that's really all that is a byte. So byte 10 seems to somehow take my color, and that would make me think, right, it takes 8 bits to specify what color is being used. And then I have a bit, true or false, to say that the light will be intermittent, it'll blink or it won't. So assumedly if that bit is high, 10.3 is high, it'll blink. If it's low, it'll not blink. A sync start and a sync impulse are on different bits, but what is it? How is this taking up 8 bits if this is 1 byte, but yet these are overlapped on it? So that is that's misleading. Now, so what I'm going to do here is I'm going to show you something that is handy and is useful for some IO-Link devices, but it's not handy for others, and it'll take some fixing. And this is one of the latter cases where it'll take some fixing, but I think it's very worthwhile showing it so that you can make up your own mind on whether here I'm going to use this for this, or I'm not going to use it, or I am going to use it and I'm going to fix it up. Something what I'm going to do. Make more sense now in a wee bit. So if I click here, all ports, right, it brings me, well, it doesn't matter if I click it or not actually. I have the option here to create PLC data type, a source file. And what this does is it's going to create a UDT file for me, not a UDT block, but a file. It's going to create me a structured piece of data with these 4 pieces of memory or 4 pieces of configurable data in some sort of a structure that I can import into my PLC program and create a UDT from. So what I'm going to do, right, is I'm going to create a PLC data type source file, which is going to capture this and it's going to store it as a file. So let's click that. And what I'm going to do here is I'm just going to save it into downloads, right? Because I'll import it into my TAA instance, and then I'm going to forget about it. I'm just going to go for Balluff. So that zip that popped up is obviously the IODD. So I'm going to go for Balluff UDT source. Just keep it that. So UDT file has been successfully created. So let's park that. Right? So sometimes that's advantageous to do. We'll see here in this one it's not so advantageous to do, but it's not disadvantageous to do either. So don't let the suspense shock you. So that's really all we have here on the slot level on the CM, the communication module level, the ports and the addresses. Right. Now when I dip down a level and I look at the actual device that is wired into the first channel, I have other things here that I could look at. Identification. It's not I can't change anything in this. These are all part and parcel from a data file in that zip file or in the IODD. So if you are creating a BOM or you're maybe outputting a report from TIA and you want a list of your components, it'll decant some of the data from this. Just the ID for the device. The parameters is useful though. So the parameters itself, these are things that I can code within that I have to code for the most part within the port configuration tool. I have to code the light directly via the port configuration tool for some parameters, some variables. So there's variables I can control the light or change the light specification at code level in TIA, for instance, different colors of light and this and that by putting in different values. But there's some things that I cannot change in TIA that have to be changed at locally, if you like, at the light. So for instance, one of them might be the blinking frequency here. So if I jump back onto the slot and I look at my my addresses, I could see here segment 1 blinks. So there's a piece of data here, a Boolean bit at 10.3 by 10 bit 3. That assumedly, as I said, if I set that to be true or set that to be 1, it's going to blink. If I set that to be false, it's gonna be solid, either solid off or solid on. But when it is set true and it blinks, what rate is it blinking at? Right? Is it blinking at half a hertz, 1 hertz, 2 hertz? What's it blinking at? I do not have the ability to change that in TIA. Where I have to change that is I need to come locally to the light. And for instance here, its blinking frequency is set here, right? Set it to 5 hertz. Now when I turn that bit high, that's going to blink away at 5 hertz. Boop, 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 boop. Right? Set it to half hertz. Bump, bump, bump. It's going to blink there at half a hertz. And I'm going to just leave it at 1 hertz. So there's sections in here, even the likes of the standard output colors, that I can change. So maybe there's LED settings. There's 4 LED settings, right? Maybe it'll give me a red, a green, an amber, blue, whatever. I might want a magenta, right? So I might have to replace a blue with a magenta here, or replace an amber with a yellow, whatever I like. So there's only certain things I can change in TIA. There's other things that must be changed in the parameters here. Okay, so that's going to vary, of course, then from IO-Link device to IO-Link device. For this light here, it's really the colors and the blinking, the rate, the flash rate, the frequency that is going to be the parameters of interest that need to be coded locally. So that's really it. Diagnostics, we can check out diagnostics. We can also check our connections, and this really is going to happen whenever we download this into the device. So what I'm going to do is I'm going to click back here onto the card, the CM card, and this is just like compiling and downloading data. I can download my TIA program onto my PLC. We're all familiar how to do that. Now what I need to do is I need to download my configuration into the IO-Link master. And what I do is I select on the IO-Link master, same as I would normally select onto my PLC folder, and I would click download. So I'm going to click this one here. I'm going to load with devices because I want to load in the configuration for not only the IODD, the parameter configurations and selections for the device, but I also want to load in the port and the address data for the communication module. So I'm just simply going to click download with devices here, and hopefully we'll get 3 green boxes returned, providing the communication is solid. This generally does not take too long. I'd expect it to finish up now very shortly. And I do believe then anytime that we did change configuration data from here on out, it tends to be a lot quicker, and we can use just the regular load one here. So there I have my 3 green ticks in the boxes: download successful, refresh status successful. That's it, we're done. So that is this port configured, right? The first channel of that IO-Link master configured to have this Balluff BNI light. Exit of that, I'm going to save these changes to the PLC. This will disappear. What I'm actually going to do is I'm going to go to Project Save As. So this is the template video just for the non-IOD, IODD or IO-Link device. I'm going to change this one for IOL. This is just a different template that has an IOL in it. And to be honest with you, I'll just ditch the old template and I'll keep this one because it is upgraded. The IO-Link additional facility in the template is not gonna negatively impact the template's ability to produce solutions if you're not using an IODD or an IO-Link device. So you just ignore it if you're not using it. So now what I'm going to do is, if you recall, I created a source file. I click create a source file from the addresses that we had. So what I want to do is external source file. I'm going to come on into here, drop that down. I'm going to add a new file. I save this member to the downloads, Balluff UDT source file. It is a UDT, right? But obviously it's not created a UDT in here just yet because this is a UDT block, right? This is a TIA object. This is just a file. So what I'm going to do, I'm going to right click that and I'm going to generate a block from source. Okay, and there it is there, just popped in that. So there is now a new UDT that is specific for that Balluff light. I'm going to F2 that and I'm going to rename it to give it a consistent name and structure with the rest of my UDTs. I'm going to go for UDT and then I'm going to go for IOL for an IO-Link device, and then I'll go for a BNI _Z036 just to identify it as that BNI, the Balluff link light Z036. Now let's have a look at the data. So this is what I was saying. Sometimes this degeneration of this UDT is helpful, other times it's not so helpful. So in here, this looks identical, same as what we had seen in the PCT under the addresses. And we could see here that this byte of data is still called the color segment 1, and then we have 4 Boolean bits. The blinking, a reserve bit, which is an empty bit, a sync start, and a sync impulse. Now, I'm going to hold this for now, but we're going to go back and see what we'll have to do. So the same way here is that I created digital inputs and digital outputs in my PLC file, or my PLC template, and then I created a tag table and I associated the UDT into the tag table. I'm going to do the exact same thing. I'm going to create a tag table, a new tag table. Now I can put it into the DIDQ, the digital output tag table, this one here, if I like. Maybe just create another one called IO-Link for the Balluff. But For IO links, I tend to like to do my own specific tag table just for IOL devices. So in that vein, I'm going to create a new tag table, F2, and I'm just going to call this IO links. The first IOL link device that I put in here is indeed for the BNI underscore Z036 light. It's not a Boolean type, but it is a UDT of that IOL. So it's the first IOL. Now, let's have a wee look at what it has done with the addressing. Now, first off, we know what this done is given it an input. It's put it onto the input register. We know it's not an input register. We can recall that from the PCT information, which indicated that it had 1 byte of output data. So I know that this is not an I, it should be a Q. I should be starting at address of byte 10, and that's grand. So that looks good until I drop this down. Now have a look. When I drop this down, because the data structure indicated that the color of segment was a byte, it gave me a full byte. So don't forget a byte is 8 bits. So this goes from 10.0 up to 10.7. So this full entire byte from 10.0 to 10.7 is for the color of segment 1. Now for all these other bits, because there's no more space in byte 10, because it's color segment 1, I've had to move on to byte 11. I've moved into a second byte. Now this is incorrect, wholly incorrect. Okay, all this data here needs to fit into the same byte. That's what it was indicated in the PCT, in the port configuration tool, that we were running with 8 bits of data, and all this data must fit in it. You'd say, well, how is that so obvious? How would you catch something like that? Well, it is something you just need to keep an eye on. So when you do IO links, it's organizing your data in the same way that you would otherwise have to organize your digital inputs and your digital outputs and your memory bits. It's just that maybe in a lot of cases with maybe non-offsets or optimized data blocks and the lesser requirements for addressing, we're just getting spoiled and taking it for granted that addressing will be looked after. It's not so much the case all the time, and this is a lovely instance of where you could get caught out very easily on it. But there's always another piece of information that when you get an IO link device that you should look at, and that's the user manual or the user data sheet, because that will give very specific configuration data as well, different values, for coding the IO link device. Not maybe configuration level ones in the PCT where we can select different flash rates and so on, but certainly for different colors. How do I get a blue? How do I get a red? How do I get a orange? How do I get a green? I need to know this data, and that will generally come in on a different file, right, which will be your user manual or your user sheet, data sheet for that. So what I'm going to do is I'm going to go look for the user data sheet for this particular IO link light. So let's try a Balluff. There is one there. User manual. User BNI IOL-800. So there is on the Balluff website. I'm able to get this user manual. And here, if I go straight down to it, I can see. I actually scoot myself. I'll just move over some controls here. From the first page on it, coming down, this is all dimensions, connections, electrical data, mechanical data, materials, accreditations, whatever. But here in chapter 4 of the IO link interface, IO link data, and the process data, output data. This is specific for me. Parameter data is what gets done in the port configuration tool. Process data is what gets done in TIA. So process data, here we go. This light, smart light, has 1 byte output process data. The output process data has different meanings depending on the selected mode. So here I can see how this 1 byte of data, whether it's at byte 0, byte 10, or byte 100, this is how it's organized. These first 3 bits are the segment color. The 4th bit is its blinks. The 5th bit's reserved. 6th, 7th, and 8th have these other parameters or variables in them. And this is how I select green. I just move 001 in red, 010 for these 3 bits. All right. So this is how I walk that. to blink it, I make sure that I set this here to 1. The setting blinks according to the blink modus settings, which is on the PCT level, or I set it to be false to turn it off. But I can see here, this is the process data. This is how buzzer state, impulse, sync, reserve bit, the blinking and the segment color fit into a single byte, which is at odds with what I am seeing here. This here, they're spread across 2 bytes. This is incorrect. And this here has been generated based off a file that was produced in the PCT from the IODD file, from the manufacturer itself. So this is a problem, and it's very easy to get caught out on it. So just watch out for that one. So to fix this, what I'm going to do is I'm just going to go back into the UDT, and instead of spitting out the dummy and saying, oh, this is a disaster, and deleting the whole lot, let's just think about what we need to do. It's handy. I'm just going to take out all this here, right? Delete that. Process data out. All the process data belongs into this 1 byte. That's it. Process data output for this light is a byte of data. I don't have to specify them individual parts. I just need to know what in that byte, that byte of 8 bits needs to be a 0, which needs to be a 1. That's all I need to do. So I just need to write that. So that's that bit done. Okay, so now, sorry, I've changed the UDT. What I want to do is I want to compile this. So this is the first compilation I've done, I believe, since I took down since I opened up the template file. So I will get the 3 warnings, which are indeed off the back that the OPC UA server is enabled, and I don't have adequate levels of encryption and password protection and so on, which is fine because there's nothing sensitive that we're doing about this here. So if I now look at my IO link device or my IO link data tag table, I can see there that I just have process data, which is a byte of data starting at byte 10. That's it. All the byte 11 references are now history. That's the way I want it. Okay, so what's next? What's next is I'm going to come into, this is the next steps really tie back to what we had done in the PLC template and the development of that PLC template. So again, if you have not seen it, it is worth your while looking at it, because this, what I'm doing now, becomes so much clearer after. I'm going to go to Program Blocks, go to My Data. I'm going to create in a new shelf in the My Data store. Again, this is an optimized data block, global data block. And in this one here, I'm going to call this one IOL underscore, let's go for BNI underscore Z036. And this is the UDT IOL BNI Z036. So in this data block, in this location, I'm going to store my process data, my byte, my octet of 1s and 0s. This is where it's going to be stored in the My Data block. And I'm going to be writing to that from the outputs, from the lights, coding. I'm going to write up what I want it to do, and I'm going to have the CP interface read what it's doing and have that translated then to a wired output. Oh, and by the way, since we configured the device in the PCT and we downloaded the device, I should have said this earlier, we can now see this light blinking, right, which means it's communicating. The reason that just popped into my head was I was going to say that the CP interface will then shoot down, it's going to relay the data entry to the actual hardwired entry down this of 1s and 0s, 24s and no 24s. So it has to be communicating for that. So where that was solid green, just indicating that it was powered and not communicating, it is now intermittent. It's a flashing green, showing that it's not only powered, but it's also it's communicating with the PLC, exchanging data. So that's now in the My Data. I'm now going to go into the CP interface. So this is my cyber physical interface indeed. I have to output some data. I have to output a byte of 1s and 0s, physically 24s and 0s. So it means I need to add in a new output. So I'm going to call this one here, let's go for BNI. I'll keep it the same actually. I'll go for IO-link BNI underscore Z036 underscore output, like so. in out, right? So this is what I'm going to fire my output to, bang. But I need to read the data coming in, right? And that's going to be read in from the my data block. So I'm going to add in a new and out, and this is a BNI underscore, oh, sorry, IOL BNI Z036, and I'll just, I don't know, call it data just to distinguish it from the output. And this is indeed a UDT IOL BNI Z036, that UDT. So that there is going to be a processed byte of data. And indeed, this one here actually should be byte. Good job. I just dropped that down and it reminded me to make sure, because I'm going to link the two of them, that's a byte of data. Obviously, I'm going to write out, knocked it there. Now, just increase my screen real estate. I have my inputs, my outputs. Indeed, these are, I'm actually going to update that to be my digital inputs, because indeed I can have IO inputs, IO link inputs, and indeed I can have IO link outputs. So let's call that digital outputs. What I'll do, I'm going to make me a new region, and I'm going to call this IO link. So here, what I'm going to do maybe is do my, not even do outputs, I'll do it on a device to device basis. So this is going to be my Balluff BNI Z036. So this is and here I'll write outputs for this device. So what I need to do here is I need to set my physical output to do what my data, my coded outputs are saying should happen. So my physical output is the IOL output. I'm going to set that equal to the IOL data dot this process data out byte. That's it. Done. So now I have association here between the physical space, the 24 volts or no 24 volts going out on 10.0, 10.1, 10.2, 10.3, so on. That is now going to be 1'd and 0'd in accordance to what I code on my PLC to be 1's and 0's, and what's going to be stored in the my data block. All right, so there's the IO link. Now I'm going to X out of that. I'm going to come into the main block, and I'm going to have to update my block call for the CP interface here. So I can compile all here. My warning should go to 0. Oh, it's still 2 hours. What am I missing here? Oh, yeah, of course. Sure, these two here. So if you didn't compile, you might right click and you can update block call here if that's surrounded in the red box. So this is my in-out, my data. My data, the data entry is in the my data block, my data dot IOL BNI. There it is. And this IOL BNI Z036 is that byte of data that is in that tag table that I created a wee bit earlier on, which is percent sign Q byte 10. There it is. So that there is PLC tags. I'm just addressing that right to this here, specifically there, percent sign QB10, that data. That's it. That's what I'm writing out to. That's where that's wired to. That's what it's going to send its data out. It's configured to there, and that's that. So let's clear them 2 hours. It looks unhealthy there, and now everything's good. Error zeros and warning zeros. So that's lovely. That's the configuration done. The only thing left to do now is to write in some code so we can update the colors or update the blinking and what have you. So where I'm going to do the coding here is going to be in the output safety independent, because this is where I store all my lights. My light data is in there. So there's lights and air supply. In my lights, I have code and energize lights, steady, flashing, or to de-energize them. Light for the push button 1, push button 2, push button 3, and push button 4, which are the integrated lamps. Behind them, push buttons, and indeed for a red, amber, and green light, if I so have them. But if I was doing Mechatronics from here on out, and I know that I have an IO link light, and I know there's 3 additional points for me to use that and to turn that on and turn that off and blink it and turn it to different colors, as opposed to using the traffic light, certainly going to use it. So I'm going to bypass this, and in this section here, I'm going to go for a let's go for a Balluff BNI IOL-800-000-Z036. Let's code that in here. And indeed, let's get another couple of spaces. So this one here is the push buttons in this block, traffic light in this block, and in this block here, I'm going to do the Balluff light. So I'm going to do this here the same way with an if statement. All right, so I'm going to say if. So this is how are we going to change the color of this light? Well, it could be based on anything. It could be based on what sequence we're running. It could be based on what mode we're running in. Are we in an initialization mode? Are we running in an automatic mode, a manual mode, a continuously looping mode, one mode and stop? Who knows? There's loads of ways that you can use lights. Put it in an error mode, unsafe mode, safety curtain light, trip mode, e-stop mode. You can put it in as a step. In step 50, the light goes on. Step 80, the light goes off. Who knows? But what we'll do is we'll put in something generic. So let's just set this up according to into run sequences. So if we're running sequence 1, let's go for green. Running sequence 2, let's go for amber. Sequence 3, let's go for red. Sequence 4, blue, blinking, or whatever. So let's try it that way. And then what we'll do is we'll enter in sequence values or sequence integers into the my data block to simulate that we're running that. So let's try this. So if management dot run sequence is equal to 1, then what I want that light to be let's go red. Let's just go red, amber, green. Then
that light bar, which is
let's go for what way will I write this one in? I'll go for Balluff. I don't really want may as well go IOL underscore BNI underscore Z036. It's a wee bit long-winded, but let's do it anyway. So if I'm in run sequence 1, then I want that byte. I want to code that byte to be red. Right? So then IOL BNI.36 dot process data out. I'm going to set that equal to. Now I want to write a byte of data. So I want to write 0111 blah 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 or 00001 whatever. To write that way, I'm going to use a specific sort of I don't know, what would you put it, syntax. And what I'm going to say on this one is that I'm going to go for a, so we want to do this, byte, hashtag, binary, hashtag, and then I'm going to write the byte, 00000000, 4 zeros, and I'm going to execute that, right? Now, I'm going to come back and change that in a second, but I'm just going to write else if, and then I'm going to take this like this, right? Control C, Control V. So if I'm into 2, and let me just, I'll do 4 of them. If I'm equal to 3, if I'm equal to 4, and then I'll just put else. I'm going to be equal to 0. Sorry for the breathing into the microphone. Let's see if I can move that down a wee bit. And if, right. So if I'm equal to 1, 2, 3, or 4, I'm going to set my byte to be certain values. So we're going to go for, let's go for red, amber, green, and flashing blue. All right. So red, what does my byte need to be for red? So I'm going to go back to this data sheet. For the, I'm going to buzzer state. I don't even know if there's a buzzer on this BNI light. Potentially there is, even though I think it is just an output light. I don't think there is a buzzer on it. We could turn the byte on and see. Sync impulse and leave that 0. Sync start, leave that 0. This is reserve bit, stays at 0. it's not blinking, I'm going to leave this at 0, but the segment color is here. So for red, I need 0, 1, 0. So specifically for this light to be red, no blinking, nothing else about it, I'm going to have a 0, 0, 0, 0, 0, 0, 1, 0. So I'm going to make this a 1. That's red. Now, if I'm running sequence 2, let's make it amber. See, do I have an amber here? There's an orange. My last 3 bits should read 1, 0, 1. I should have a 1, 0, 1. My green for the next one. Green should be 0, 0, 1. 0, 0, 1. And then 4, I said let's go flashing blue. So blue is 100. My last 3, 100. That's solid blue. But to flash it, blink, I need to make bit 3 1. So here needs to be 1 as well. So I should see 0, 0, 0, 0, 1, 1, 0, 0. So this also should be a 1. And that's it. Or else if none of these are the case, then I put this into the wrong one, apologies. Just took it for granted it was the last one, I put it into the last one. So if I make the 4, do the flash and blue light here, or else if I'm not equal to 1, 2, 3, or 4, just turn everything off. That's what I'm saying there. Okay, let's get that lights in, done. I'm gonna X out of this, X out of this. I may as well X out of that. Click on the Sean's PLC. I'm going to compile. Now, of course, I added the new parameter to the block, the safety independent block. I need to address that to my data block. Then just after 11, it's getting late. There it is there. I need to address that to my data block. IOL. All right, that should remedy that. Let's X that one again. Let's try one more time. Compile. All good. 0 errors, 0 warnings. Let's download on into the device. So defaulting, we should be in. There's a pink field. Let's change that. We should be in run sequence 0. So our light should be off. Data light is off. Now I'm going to go on into my data block where I store my data and go into management where I store my run sequence and run mode. I'm going to take myself online here, and what I can do is I can update these values. So we were going for red, orange, green, blue flash in accordance to 1, 2, 3, 4 respectively. So I'm going to move this to modify the value 1, and hopefully this goes red, which it does. Then modify the value 2, orange. Does hard to see there, I do appreciate, but I promise you that is orange. 3, green. And 4, blue flash. There we are. And then 5, 0, because else it was off. So 0, just leave that back to 0. Okay, come offline there. That's it. That is a IO link light now added into this PLC template. It's, mind you, configured for a Balluff light, but again, if you were given a Festo airflow sensor or a Festo pressure sensor, you'd follow the exact same procedures that I did. Device configuration, right-click Start Device Tool, bring in the IODD file, make sure you drag and drop the file into the port that the device is wired into. We didn't change any parameters locally. It might just actually do that. If you just, I know we're at 53 minutes, this is getting a wee bit long, but I'm just going to try this. So we've seen that flash rate. What I'm going to do is I'm going to, at the risk of flipping, knocking myself out with high intensity, high frequency flash and light, I'll increase the flash rate here locally to 5 Hertz on this. So slot 1, I'll go into here, parameters, 1 hertz. Let's change this on down to 5 hertz of a flash rate. Okay, so I'm going to download this back into the devices. Bump, 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 bump. All right, so that's that. So we don't have to download it, load with devices now. I think we should just change the parameter settings. You can just load and X out of that. Let's save that up and let's go back online. So we don't have to re-download anything into PLC because it's just the network card that we have updated. Let's go online. I'm going to come back into the My Data. Management, run sequence. Let's go online, and the flash was in sequence number 4 with the blue light, and there we are, flashing at a much higher rate of 5 hertz. Get that off here quick, or I blind myself. So again, that's set locally within. So that's how you might have to configure a particular device to do or to behave in a manner that isn't specified within code, within SCL or ladder or whatever other language that you're coding in. And then after that, again, if you're using my sort of template way here and you have a CP interface, what you'll do is you'll tie everything together using the UDT. So that's it. So with this PLC, this template that we have now, if you are in automation or you're in mechatronics in UK WorldSkills and in, I suppose, what is going to be the 5.5 weeks, so that maybe 6 weeks, you are faced with a regional qualifier for UK finals and you're badly stuck for task C, or you're looking a quicker, maybe a different way of coding your PLC. Maybe this template could have or present a viable option for you. So if it does, do hit the like on this here, hit a subscribe on it, because if you do, what you'll get is first notice as well of the 2024 Mechatronics regional final task, which I will tackle in the next video, which incorporates this IO link light. So what we'll do is we'll actually code the light for a real competition specification and get a solution for it and make sure everything works. So if you are taking it forward into practice, at least you'll have a record of how 2024, and indeed I'll do 2025 as well, has been done. They're very similar. So yeah, so thanks very much for having a look at the video, and hopefully you stuck with me through the whole lot of it. And I hope you do come back and look at a couple of other videos there in the playlist here and other ones across the channel. So thanks again, and see you.